Okay, good evening. Welcome to
Twitter math number 9.
Twitter Math number 9. So today we have a problem from our friends at Five Triangles. Sorry, I banged the wall. Our friends at Five Triangles, and we haven't done a Five Triangles problem in a while, but they do really cool problems. Their problems are geared towards
6th and 8th, I think.
6th up to 8th graders, yeah. And you're a little bit younger, but that's fine. So this one's best kind of illustrated with a pattern. That's why I didn't write out the problem. I just drew the picture. So you have a square, a 1 by 1 square, and you're successively cutting everything in half. So you have half the square, then you have a quarter of the square, then you have an eighth, a 16th, 32nd, a 64th. Do you see the pattern? Okay, what's this next shaded in one going to be up here?
That would be 1 256.
1 256, good. And then the question is, you're supposed to add up the areas that are shaded in here, or the actual question is come up with a plan and how you would want to add those up. Okay. Now, what are some things that you notice, or what are some ideas you have about this picture? Because it's kind of a neat picture.
The sum is going to be greater than 1/4.
Okay. Why is that?
Because this is 1/4 right here.
Okay.
So x is greater than 1/4.
What is x?
X is our number that we're trying to find out.
The sum. Okay.
Yeah, the sum.
Cool.
And it's less than 1/2.
All right. Why is it less than a half?
Well, because I don't think it's going to add up to this big non-shaded area.
Okay, it's not going to add up to something this big. What makes you think that?
Well, you start out with something half as big.
Uh-huh.
Then you add something on as quarter as big.
Okay.
And then eighth as big.
All right. So, for example, this whole thing here, this rectangle here is a half, and we're missing big chunks of that rectangle.
Yeah.
Okay.
The bigger part.
All right, that's a good observation. So it's going to be between a quarter and a half. Does it give you any guesses?
Could be 1/3.
Well, okay. 1/3 is right in between. All right. So we have a guess. 1/3. Why not?
So,
it's in between a quarter and a half?
Yeah. So how would we add them up?
Yeah. How would we think about this?
Well, we know when we add 1/2 plus 1/4 plus 1/8 plus 1/16 plus all the way out to infinity, you're going to get 1.
Okay, why is that? I'm going to write that over here because that's an important thing, and we're going to need to play around with that. Half. Explain why that's
true.
Explain why from the picture, for example.
Well, if I make an easier graph to see, you got half of it, then you add on half of that, and then half of that, and then half of that, all the way up.
And eventually you add up to the whole thing?
Yeah.
Okay. Another way to see it, by the way, is this square has area 1,
Yes.
and it's a half plus a fourth plus an eighth plus a 16th, 32nd. So it looks like we add up to the full square.
Yes.
Now instead, what they're asking us to do here is add up only every other term. A fourth plus a 16th plus a 64, and then you were right, the next term is 1 256. Okay, so we have to figure out, can we say anything about every other term? Either from this sequence of numbers or even from the picture.
Well,
can you see any relationship?
when you go from number to number, you multiply each one by 4.
How, what do you mean? What's 1/4 times 4?
No, I mean you multiply by 1/4.
By 1/4 when you go from term to term. That's even true in this sequence too, that we're not adding up. Do you see any relationship between the two sequences?
Well, you multiply by 2 to get from. You multiply this term by 1/2. This term by. To get from each one, you multiply by 1/2.
Okay, so to get from this sequence here to the circled sequence, we always are multiplying by 1/2.
Yes.
Okay. Does that give you any hint about what the sum of this sequence might be in relation to the sum of this sequence?
Well, the denominators. This sequence that we're trying to add up could be half of what this other sequence is.
Ah, great. Now you called the sequence we're trying to add up x. So what would this other sequence be?
2x. And 2x. So 3x, we know 3x would equal 1.
Aha.
So x does equal 1/3.
How about that? That is a really cool problem, isn't it?
Yeah.
Now, by the way, can you see from the geometry, not just from the numbers, can you see in the picture where the 1/2 relationship is? How do I get from here to here multiplying by 1/2, or from here to here multiplying by 2?
Well, you cut it in half.
Now, look at it right in the picture. It's right, this might be a hard point to see. It's right in the picture. How do I get from the 4th plus the 16th plus the 64th by multiplying everything by 2 to get to 1/2 to 1/8 to 32nd? Do you see it in the picture?
Well, yeah, everything doubles in size.
Everything doubles in size. It's kind of like a fractal,
shrunk,
right?
Shrunk.
All these squares turn into these rectangles when you multiply them by 2. So we do actually have this sequence here, which is twice the size of this. So this sequence is 2x, that sequence is x, 3x equals 1, x equals 1/3. Pretty neat problem, right?
Yeah.
I like their 5 triangles problems. They really make you think.
Yep.
They're really good problems. All right, good job, hun.